Okay, we're looking at this equation, y equals 5 times 1/2 to the x, and we're asked to graph it, and we're asked to identify the domain and range. Now, one thing I want to point out here is that you want to recognize the form anytime you're graphing. So here, what we have is the x in the exponent, which is a big indicator that we are graphing an exponential function. And right now, this is an exponential function that just has a starting value here at 5 and a multiplier of 1/2. So we're repeatedly multiplying by 1/2. We begin with the number 5. So it's 5, and then it's times x values of 1/2. The general form that we have talked about is this. A b to the x. A is the starting value. And remember, we start when x is 0. And then b is the multiplier. So if you know all that, you can actually graph without setting up a table at all. This is going to begin at 5, and then I'm going to keep taking half of that value as I go out for values of x. So this is going to be a function starting at 5, and then half, and then half, and then half. It's going to get this nice little shape. Going the other direction, it's doubling. So let me show you what I mean by setting up a coordinate grid, and then I can also show you how you would use a table to graph the same relationship. So I want to set it up nice and low so there's plenty of room in the positive y direction. Okay, so let's see. Let's go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. There's 10. There's -5. We won't need any negative y values, and I know that because there's no power I could put on any positive base and get a negative output. If I have a negative exponent, it's going to be the reciprocal of the base. All right, so there's my y-axis. Here's my x-axis. All right, so if I know the general form, if I know y equals a times b to the x, if I know this, and I know a is my starting value and b is my multiplier, then I can actually immediately start just plotting points. When x is 0, my a is my starting value, that's 5. So I can go right to the graph and I can mark 5. And then what I'm going to do is I move out here to x equals 1, x equals 2, x equals 3. As I increase these values of x, I'm going to keep multiplying that value by 1/2. So as I go 1 unit to the right, x equals 1, I'm going to do 1/2 of 5, which is 2 1/2. And then I'm going to do 1/2 of 2 1/2, which is 1 1/4. So 1 1/4. And you could think of this as the actual numbers, or you can just do 1/2 of the height, right? 5 times 1/2, 2 1/2, 2.5 times 1/2, 1 1/4, 1 1/4 times 1/2. All right, I'm going to get 0.625. So as you can see, I'm just getting kind of lower and lower, and then I'm going to do 1/2 of that height. And at this point, knowing the decimal is probably not even that helpful because, this is 0, this is 1, those decimal values. So I just start thinking about 1/2 the height, and just keep getting lower and lower and lower and lower. Now, as I go the opposite direction, and it's easy to see with 2 1/2 to 5, right? I'm doubling. So as I go 1 unit over here to this way, I'm all the way up at 10. And then doubling from there, I'm off the graph, I'm at 20. So that is really my curve. I'm here, and these are going to connect. It's an exponential curve. So this is the shape that I anticipated to see. Exponential graphs take this sort of curve shape. They're never going to go below the x-axis. And again, that's because I can never get a negative output if my base is 1/2, right? If I take my 1/2, and I raise that to a positive number, right, I get a positive decimal, and I would just multiply that by 5. But even if I do 1/2 and I raise that to a negative number, I still get a positive output. All right, that is a positive. There's like a scratch on my computer screen. It makes it look like that was a negative. That's a positive 32, right? So even if I take my base and I raise it to a negative exponent, so over here, I'm still going to get a positive number. So there is what we call an asymptote here at x equals 0. And I'll just graph that in. It's not technically part of the graph itself, but it's something that exists in an exponential relationship. The curve will never go below that. So I'll just label this here as an asymptote. And that happens at x equals 0. All of my values are going to stay above 0. Okay, I also said I would show you how to use the table. So if you didn't remember that relationship, you can also just set up a table. So we'll do that here, all right, little x and y. Now this one doesn't have a vertex. So there's no like center point that you need to find to put in the center of the table. So we can do kind of standard inputs from -2 to 2. And then I can just start plugging those numbers into the calculator, right? If I do 5 times 1/2 and I raise that, not divided by, raise that. Now, very important when I'm doing in the calculator a -2, I need to put that in parentheses. So you can see that's going to give me 20. And that was a value that I already knew was going to appear, right? When we were graphing this kind of conceptually, when I was here at 5, I backed it up. Oh, yeah, a -10, and then I said -20 would be off the graph. So my next one, when I do -1, I should be at 10. I'll just bring this guy up, change that to a 1. Yeah, see 10. Bring that back, change this to a 0. 5 times 1/2 to the 0. We're at 5. That was the starting value. Like we knew at x equals 0, a was going to be the starting value. A is 5. One more time, we'll go to 1. We knew it was going to be 2.5. And then the next one's going to be 1 1/4. Make this 2. So I could have plots or points to plot from there as well. Okay, so now the last thing that we need to identify is the domain and range. And the domain for this function, this graph is good. This curve is going to go forever to the left and the right. There is no restriction on what I can input for x. I can do any value. So the domain is all real numbers. X is all real numbers. And that's one of the notations for it. X is in the element of a real number set. Our range. Now the range does have a restriction. The y values do not go forever up and down. They are bounded by this asymptote, right? The curve is never going to go below that. So we're going to do y is all real numbers as long as y stays above equal. Oh, and I have a little mistake there. I put y is greater than or equal to. It's actually never going to get down to 0. It stays above the asymptote. So I really need to actually get rid of that little guy. Now it's accurate. Y is above 0. Okay, that's a great graph. I hope that's helpful. Message me anytime with questions.